In this video, I'm going to show you how to use the UART with the Nucleo board. So first, I'm going to open my STM32 QMX. So access to the board selector. It's under the Nucleo 64, and I'll select the board that I have, which is the L053. Double click and initialize everything in to their default mode. The board doesn't come with the high-speed crystal, so I can set these two pins into reset state. Usually I will set the clock peripherals configuration to 60 MHz. By default, the UART has already been assigned to the PA2 and PA13. Click under the connectivity, UART2. The baud rate is default is 112.115.200 bits per second. Everything will be set to default, and we go to the NVIC settings and enable the interrupt. I'm going to call this test _UART. MDK arm, since we're going to use the Callback vision, generate the code. In the while loop, I'm going to send a message of how are you through the UART. Let's call the data data transmit. So I put it under the user code begin private variables. The size of data and 1 millisecond delay. We're going to send this message every second, so put a delay here. Let's compile. There's an error message. Let's look at the error. I do not need this window, and this window I can close it, and let's run. Okay, we can use a program. Let's use a Terraterm, which you can download free from the internet. So we have to select the correct port, which says STM Microelectronics ST-Link. Click OK. you have to go to the setup, under the serial port, set the baud rate. Okay, this appear because of the message we send is only for new line. If you look at the data transmit here is how are you, new line. So over here we can go to the terminal and set the receive to line feed. Line feed is the new line. Okay. So now let's try to receive data from the Terra term. For the receive, we are going to use the interrupt. So before the 1-1, we can introduce the receive, UART receive. Using the interrupt. And we need a data array, so let's call this data receive, and the size of data receive, let's give one and that's all. So over here, going to introduce the array for data receive. Again, I'll put 20 bytes. Okay, let's run. Let's put the data receive to the watch one so that we can see the values that's been transmitted from my Terra term. Okay, so these are my data received, 20 bytes. But I still keep sending from the STM32 to my computer through the Terra term. I can also send back from a Terra term, but before that, let's do a setup and change this to local echo so that I can see what I'm typing on the Terra term. So let's try test, and it appears here immediately, test. So let's see, I am fine. How about you? Okay, notice that because it has reached the end of the buffer, 20 byte of data received. Now wherever I type here, it does not will not clear. Okay, so in our, we can go to the interrupt C files and look for the UART data queue handler. Go to the definition and look for the receive complete callback. And this function is not doing anything, so we can copy the whole function, and in the C files, in the main.c, we're going to put it in the user code begin for, and going to override the function. I'm going to include the string.h. So this is for convenience to clear the array. So when we receive the callback that's the 20 byte data received has already been used up, so we're going to use the memory set to clear the buffer. and then we have to reset again. Okay, make sure there's no error, and then we'll debug again. Let's run it. So let's put test. How are you doing? So every time I reach the 20 byte, it will goes into the callback and clear the buffer, and you can retype everything again. Okay, so we can also use the direct memory access. So we go back to the QMX again, and using the direct memory access, we select the UART only receive, because of transmit we do not need to use the direct memory access, but for receive we have to put the received data into the buffer, and the mode we set is circular. In the normal mode, it will stop when it reaches the end of the buffer, 20 bytes. So in circular, it will just override every time the new information comes in. Okay, memory will be byte, so everything will be the same. So we try more that again, generate the code. So over here, we do not need to use the receive callback anymore, so we can delete this. And the receive interrupt will change to DMA, the memory access. Okay, compile. I'm going to clear the window so that we can see the running of the code. So every time I type anything from the tail term, it will be reflected in the buffer here, data received. So even when it reach the end of the buffer, it will continue from the top. So let's say 1 2 3 4 5 6 7 8 9 0 1 2 3 4 5 6 7 8 9 0. Okay, so that's the end of the video.